We have data, so much data, all around us. To handle it effectively, we turn to data structures, the backbone of how everything works in technology. But what is a data structure? It's a way to organize and store data so we can use it effectively, whether it's a simple list of numbers or a complex network of connections. Data structures gives us the tools to manage information, solve problems, and make technology works seamlessly. But there's no single data structure that fits every need. That's why we have many, classified into linear structures and nonlinear structures. Each serves a specific purpose in organizing and managing data efficiently. Linear data structures. First, let's talk about linear data structures. These are the building blocks that store elements in a sequential order, much like a line of people. It can be numbers, alphabets, or even objects. There are 4 primary types of linear data structures: arrays, stacks, queues, and linked lists. First, let's talk about arrays. An array is a linear data structure that stores a fixed size sequence of elements of the same data type. Each element in an array is accessed using an index, which represents its position in the sequence. Next is stack. A stack is a linear data structure that follows the last in first out LIFO principle, meaning the last element added to the stack is the first one to be removed. It supports 2 main operations, push and pop. Push, which adds an element to the top of the stack, and pop, which removes the top element from the stack. Queues. A queue is a linear data structure that follows the first in first out FIFO principle, meaning the first element added is the first to be removed. It supports 2 primary operations, Enqueue and Dequeue. Enqueue, which adds an element to the rear, and Dequeue, which removes an element from the front. Then we have linked list. A linked list is a linear data structure where elements, called nodes, are connected by pointers. Each node contains the data and a reference to the next node in the sequence. Linked list allows dynamic memory allocation, making them flexible for inserting or deleting elements without needing to shift other elements. It has 3 common types, which are singly linked list, doubly linked list, and circular linked list. Nonlinear data structures. Now that we have covered linear data structures, let's move on to the nonlinear data structures. Unlike linear data structures, nonlinear structures organize data in a hierarchical or interconnected manner, allowing multiple relationships between elements. This makes them ideal for representing complex relationships and solving advanced problems. There are 2 primary types of nonlinear data structures, trees and graphs. A tree is a hierarchical data structure consisting of nodes, where each node is connected to one or more child nodes, starting with a single root node. It starts with one root node at the top and branches downwards to form connections. Each node can have multiple children, but only one parent, and there are no loops in a tree structure. Types of trees. Binary tree. A binary tree is a tree where each node has at most 2 children, known as the left child and the right child. Binary trees are foundational in computer science and are used for tasks like expression parsing and data sorting. Binary search tree, BST, an upgraded version of a binary tree where the left child contains smaller values and the right child contains larger values than the parent node. BSTs. Binary search trees are optimized for quick searching, insertion, and deletion of data. The sorted order ensures efficiency. Heap. Heap is a binary tree where the parent node is always greater or smaller than the child nodes. Heaps are used in algorithms where priority is important, such as scheduling tasks or finding the smallest element. AVL tree. AVL tree is a self-balancing binary search tree where the difference in height between the left and the right subtrees of any node is at most 1. AVL trees automatically balance themselves after insertion or deletion, ensuring optimal search time. They are a refined version of binary search trees for better efficiency. Graphs. A graph is a data structure consisting of nodes connected by edges. Unlike trees, graphs are about relationships and connections, not hierarchy. Graphs can represent anything from social networks to city maps. Nodes are the objects, and edges are the relationships between them. Types of graphs. Directed graph. Directed graph, also known as digraph, is a graph where edges have a direction, indicating a one-way relationship between nodes. For example, on Instagram, if you follow someone, they might not follow you back. Undirected graph, a graph where edges have no directions, indicating a two-way relationship between nodes. For example, a Facebook friendship network where being friends is mutual. Weighted graph, a graph where edges have weights, representing values like distance, cost, or time. For example, a Google Maps route, where each edge has a distance or travel time associated with it.